Hey friends, it is so great to have second semester started again. Now, remember, these are videos of the notes we take in class, but however, they're not always going to be exactly what we do in class because each class is different. But you will always get the basic idea. Second of all, I go fast. You all know me well enough to know that. So what I'm going to ask you to do is stop, write down what you need to, go back, rewind it, and play it again. Something I don't do that often in class unless you guys say, hey, could you repeat that for me? So I completely understand if you need to stop, replay. Also with these, just kind of remember I do a page at a time, so some are going to be longer, some are going to be shorter. Anytime that you have questions, make sure you call me at home too. I would love to give you the information that you need. So let's go ahead and do a quick review from the beginning of chapter 6. I asked you in class to try to do at least the first 4, and then we did 5 through 6 together. So remember, we have to be able to define a parallelogram. Well, I asked those of you who are visual to at least draw the diagram. Remember, a parallelogram symbol is the only symbol for quadrilaterals that we have. But the basic definition is it's a quadrilateral with 2 pairs of opposite sides parallel. And when you think about it, it's not that big of a deal because it's a parallelogram. So that should be the first thing you always mark, the pairs of parallel sides. Then we also had the fact we had a kite. And now a kite, if you remember what it looks like, is Charlie Brown's kite. It should look something like this. Now a kite will never, ever, ever have parallel sides. So think about it kind of like this. It's a quadrilateral with no parallel sides and exactly 2 pairs of consecutive, sometimes we use adjacent, sides congruent. So those 2 would be this way, those 2. And when we say exactly 2 pairs, well, that keeps it from like having all the sides congruent to each other, which makes it a parallelogram. And then we had a trapezoid. Now with a trapezoid, it could look a lot of different ways. But what was the key thing about a trapezoid? That's right, it's going to have a pair of parallel sides and only one pair. So when we describe what a trapezoid is, we're going to say it's a quadrilateral with exactly 1 pair of opposite sides parallel. Keep it really simple. Now, when you do it, remember also trapezoids could look a lot of different ways. Okay, so that's another way of forming a trapezoid. So we have to think of that later when we're working with those. Then I also asked you what are the properties of a parallelogram. And those were really critical. And if you were in my class, I would sit there and say, okay, repeat after me, opposite sides are what? And we'd repeat. Well, on this one, the opposite sides are parallel is the first thing you need to remember. So and that's what we always mark. So we have our parallel sides. Then we always say the opposite sides are congruent. And if you want to do visuals of this, it's just a great reminder how we can prove these and be able to work with them. These were critical. Opposite angles are always congruent. So if this was my diagram, I know those would be my pairs of congruent angles. The diagonals, what do? They bisect each other. So we know that if I have my diagonals, those 2 would be the same, and those 2 segments would be the same every single time. And then we have our consecutive angles. And our consecutive angles, remember, are the same thing as same side interior angles. So, and what do we know about same side interior angles when I have parallel sides? Right, they're supplementary. So our consecutive angles are supplementary. And so we know, like A and B here would be supplementary. Those are consecutive. After we went through those in class, I asked her, like, let's apply those properties now. Like, for instance, I want to find the measure of angle Z. Well, the sides don't help me with that, except for the fact I know it's a parallelogram and I have my opposite sides are parallel. As a result, these two are consecutive angles. And what do we know about consecutive angles? Consecutive angles are supplementary. So I know I can add them up together to be 180 degrees. So I just go 9b plus 2 plus 18b minus 11 is equal to 180. Before we start solving the equation, please combine like terms on the same side. So that's going to be 27b minus 9 is equal to 180 degrees. And then when we work with it, we're going to add the 9 over. So I get 189, divide by 27. I'm going to move this over here. B is going to be equal to, in this case, 7. But we're not done. Instead, we got to plug it in, right? And so we're going to find the measure of angle Z by plugging in the 7. So we go 9 times 7 plus 2. 9 times 7 is 63, plus 2 is 65 degrees. That's your measure of angle Z. Now, let's do the same type of a stuff that we're working with a parallelogram, so I always mark my parallel sides first. And I want to look for the length of segment JG. Well, that's part of a diagonal. But what do we know about the diagonals? I look back in my notes. The diagonals bisect each other. So I know that those two are the same and those two are the same. Now I'm looking for JG, so do I really have to worry about my variable Z or anything? No. Instead, I can set these two equal to each other. So I get 3W is equal to W plus 8. Subtract W, you get 2W is equal to 8. Divide by 2, W is equal to 4. Then I just plug it in. So the length of segment JG, and by the way, I sing, so I sing out the answers, I guess. So you go 4 plus 8 is equal to 12. Hopefully that will help you a little bit with those. And again, no correct notation, no bar over the top. Well, we're going to review. In fact, I'm even going to change that word to quadrilateral. You could change it with either one. What a rectangle is. A rectangle is a quadrilateral with, we could say, 4 congruent angles, or you could say 4 right angles. I'm happy with it either way. But when you have a rectangle, you should mark the right angles. Now, with that, we could also call it an equiangular quadrilateral. That's kind of our other definition we could use for that. All right, now we're going to use this definition and we're going to build some properties off of this one. So we're going to go to the next page.